So, hey guys, we are going to go ahead and continue on with chapter 14. So, this is part 2, and we'll be talking about esters. So, specifically, the formation of esters, and then I guess the breaking apart of esters as well as our normal naming and properties that we talk about. So, esters contain a Esters are the functional group that we know. They contain a carbonyl next to an ether, or really just next to an OR group. So where R is another rest of the molecule. So it looks like this here is a very basic version of an ester. So characteristics and uses of these, in general, they have pretty pleasant aromas and taste. So they're used a lot in essential oils, and a lot of the typical things that you taste, like in fruits and stuff like that, are a lot of esters. And then also in perfumes. So typically esters are one of the main ingredients in perfumes. In terms of esters cannot ionize, meaning there's no hydrogen atom that we can remove with an acid-base reaction easily to make an ion like we could for carboxylic acid. So because they can't ionize as easily, they're not quite as soluble as carboxylic acids. They're probably more on terms of like ethers than they would be carboxylic acids in terms of solubility. And they're also only hydrogen bond acceptors. So as you notice, you only have the actual hydrogen of the water doing a hydrogen bonding interaction with the oxygen. There's no hydrogens on an ester that can do a hydrogen bond to the oxygen of water. So this is called an H bond acceptor. So this is all esters can do, is that kind of accepting overall functionality. So it doesn't make it nearly as soluble. We're not going to worry about a specific chart for these. In general, they're more slightly soluble to insoluble. So we're not going to worry about a chart or ranking solubility for esters. And then here's a couple common esters for you guys to look at. As I was saying, a lot of different fruits, and I guess on here it's just mostly fruits, but a lot of different fruits have one of their primary ingredients are esters. And so literally just changing the chain length can change what it smells like to us. So going from a propyl group on here, so we'll talk about naming in just a little while, but going from a propyl group to a pentyl group, just adding 2 carbons makes it go from the smell of pears to the smell of bananas. We also have oranges with octyl acetate. We have pineapples, apricots, cherry grape, raspberry. All of these different flavors and smells are common of esters. And then also they're not necessarily all 100% good. I don't personally mind these smells, but I know a lot of people don't like the smell of nail polish remover, which is typically ethyl acetate or acetone. Ethyl acetate is also the main ingredient for the actual nail polish itself. So that's like the liquidy part that when you put nail polish on your nails, it's the liquidy part and then that evaporates and dries, and that's what leaves the nail polish on your nail. That's just for normal nail polish. Gel manicures are different, or like anything where you have to put your hand in the light, that's different. Don't worry about that. And then there's also methyl acetate, which is a big component in glue. It's the same thing. They add this organic compound that it's pretty volatile. And so when you add glue to something, you have this methyl acetate here, this organic molecule that will evaporate pretty quickly, faster than water would evaporate to dry whatever you're gluing together. So those are some of the properties and some common esters. We will talk about the different reactions as well as naming coming up shortly. See you guys there.